Hey guys, it's your favorite TA here. We are doing experiment 5 this week, which is dealing with phosphorus in fertilizer. So we're going to be doing a quantitative chemistry technique called gravimetric analysis. If you want to know how to spell that, it's at the top of your theory for this experiment. But basically, gravimetric analysis is using our example, we're going to separate phosphorus out from a given sample of fertilizer so that we can quantify or find out how much is in that given sample. So nothing too difficult or fancy. Fortunately, last week you guys used some of the same equipment, so hopefully you all got good practice and will be super efficient at it this week. So let's go ahead and jump into the procedure so that we can talk about the data sheet at the end. All right, so starting out, number 1 tells you to get about a gram of the fertilizer sample. We will have 2 samples that you guys could potentially use, so you'll either have 11, 15, 11 or 13, 13, 13, okay? So that will be what it looks like. It tells you can crush your sample with a mortar and pestle, put it on a weigh boat, weigh it, and record your exact mass on your data sheet. So this is a mortar and pestle. A lot of you probably already knew what this is and what it looked like. Because we don't want every group to have to mash up their own sample, it would take a good bit of time. You can actually work with several other groups to go ahead and grind up a large amount of the fertilizer, and then you can all take from the ground up sample and then weigh your 1 gram from the same mortar and pestle, okay? And if you do it right, it should be a pretty fine powder. I'm not sure if you can actually see in there, there's some in there. But you'll still have some large chunks, and that's okay. Don't waste your time trying to grind down every single chunk of fertilizer. Some of them are not easy to grind. Okay, but anyway, get your 1 gram sample and then record that on your data sheet. Step 2 tells you to put your sample into a 250 ml beaker and add 15 mils of distilled water, stir it, and it also tells you that your solution is probably going to be cloudy and that there will be some particles that don't dissolve. That is the case. So just so y'all can see it, I'm going to have some samples along the way. But you can tell I definitely have some large particles in the bottom of this. But like I said, some of the pieces of fertilizer are really hard to grind down to that fine powder. But either way, you'll still have a cloudy solution and you'll still get some decent results. So don't fret if you see some large pieces in the bottom. Step 3 tells you to set up suction filtration. You guys did this last week where you had a flask with a side arm, a large rubber hose, and then your Buchner funnel. So don't forget to cut your filter paper down to size. They will probably be much larger than your actual funnel. And you can do it how I showed you last week or trace it however you prefer to do that. It tells you to filter the undissolved particles, so the particles that were very large and you can actually see in the bottom of the beaker. You're going to be separating those out from the liquid from the solution. And so you're actually going to be doing 2 filtrations. For this first one, you want the liquid. So whatever liquid you collect in the bottom of this for this first filtration, you want to keep that. So while it's separating out the larger particles from the solution, one of you needs to get the beaker that you were using, go wash it, and then rinse it with distilled water so that we're not getting anything from the tap water. Because you're going to be pouring that liquid back into the same beaker. Okay, and note that it also tells you not to add too much water when you're rinsing the beaker out to make sure you get all the large particles, because we are focused on the concentration. So if you lower the concentration, you'll have a harder time in the next couple of steps getting your solution to be basic. So if you do everything right and you don't add too much extra, then you won't need much more than what the procedure actually tells you. Okay, and of course you can put your filter paper in the garbage, and that filter paper will have the large particles. So I'll show you what that looks like. This was after this first filtration, so I have all the large particles that wouldn't go through the funnel on my filter paper. And then in my beaker, I'm going to pour the liquid from the filter flask back into the beaker. And now you can see that my solution is still cloudy, but I don't have any of those large particles in it. And this is what we want. So step 4 tells you to measure out 15 mils of 10% magnesium sulfate heptahydrate into a graduated cylinder and add that to your beaker. Step 5 tells you to get 15 mils of 1 molar ammonium hydroxide. Make sure that you don't have any of the previous solution left in your cylinder. Wash it out, okay, before you put the ammonium hydroxide in. And also, you guys will actually have 1 molar ammonia. They're both a base, so don't panic if you can't find one that says 1 molar ammonium hydroxide. The 1 molar ammonia will be fine. And then it tells you in all caps to slowly, over the course of a minute, pour that ammonia into your mixture and stir continuously. So one of you can be stirring with your stirring rod, the other one of you can be slowly pouring this in. And so when it tells you over the course of a minute, that doesn't mean to pour the ammonia in at one time and then stir for a minute. And it doesn't mean to put half in, stir, and then put the other half in and stir. It needs to be just a little bit at a time. It doesn't have to be like a continuous stream from the graduated cylinder, but it just needs to be in smaller amounts than half and half. So just the slower you go, the better it'll probably turn out. And then it tells you after you've added the 15 mils, you want to test to see if it's basic. But we're going to do that using red litmus paper. So if y'all are familiar with litmus paper, blue litmus paper will turn red if your solution is acidic, and red litmus paper will turn blue if your solution is basic. So here is my container of red litmus paper, and all I did was get 1 strip out. And a common mistake people make when using litmus paper is that they want to take the paper and dip it into their solution. This is not correct. You can actually contaminate your sample if you do it too many times. So the actual way that you guys want to do this is to take your stirring rod, and then you're going to dip the end into your solution, and then you're going to actually touch that to the paper. And as you can see, I have a blue spot where I just touched it, so my solution is in fact basic. Okay, so that's the proper way to use the litmus paper. Don't dip the whole strip into the container. Okay, and then it tells you if your solution's not basic, and so it wouldn't turn blue if it wasn't basic, then you're going to need to add more of the ammonia, 1 milliliter at a time, and after every time you add a milliliter, you're going to test again. But hopefully you guys don't have to add any more. Hopefully you have a concentrated solution and that 15 mils will be enough. Step 6 tells you to let the reaction mixture sit undisturbed for 10 minutes to make sure that the reaction is complete for you to get your precipitate. And so while you're waiting in those 10 minutes, you can go ahead and clean out your Buechner funnel, your filter flask, and then go ahead and cut a new piece of filter paper out to the right size for your next filtration. But for that beaker, I wouldn't, as soon as you've poured that in and you know that it's basic, I would kind of move it out to the side where you know you're not going to have to disturb it for those 10 minutes. Because if you just leave it in the middle of your bench, chances are you'll probably be moving around and you have the chance of knocking it over, or you're going to have to pick it up and move it. And so we don't want to do that. We don't want to have to touch it in those 10 minutes. Step 7 tells you to get a new piece of filter paper, put it on a watch glass, and weight them together. So we actually did that at the end of last week's experiment. So be sure that when you cut your filter paper, or when you weigh your filter paper in a watch glass, that you cut your filter paper to the right size. So don't get a full size filter paper and weigh it with your watch glass and then cut the filter paper. That's not the right mass. You want the pre-cut filter paper with the watch glass. And this is the one that you'll record on the data sheet. Okay. Step 8 tells you to put the piece of filter paper into the funnel and then to wet the filter paper with 70% isopropyl alcohol. So that will have a pipette with it. You can just draw up a mill and just wet the filter paper. Step 9 tells you that after your 10 minutes of letting that mixture sit in the beaker are done, then to collect the solid that forms on the funnel. So once it's done, and I don't know if you'll be able to see it, but I actually have white solid in the bottom of my beaker that I let sit undisturbed. It's not a large solid like y'all have been dealing with. It's very fine. It almost looks like it's a liquid moving inside itself, but it's not. It's actually a solid. It's just super, super fine. But it is white, so if it's not white when you guys do it, then there is probably a problem. Let's see, back to step 9. Yeah, to make sure you want to get all the solid out of that beaker, so just kind of tilt your beaker down towards the funnel and rinse it out with some more isopropyl alcohol. And we're not worried this time about how much rinse we use, so you can use as much as you need to get all that solid out and onto that filter paper. Step 10 tells you, so once you're done rinsing from the beaker into the funnel, then you can rinse the actual solid that is in the funnel. So just draw up the pipette a few times with that isopropyl alcohol. Make sure you cover the entire surface of that filter paper once or twice. Don't just put it in the same spot, because then you're not rinsing all of the solid and it won't all dry evenly. Step 11 tells you to leave the suction on for an additional 5 minutes to help dry the solid. So if y'all have anything that you need to wash or clean up, y'all can be doing that in that 5 minutes. Step 12 tells you to turn off the suction, remove the filter paper. You guys can do that with a pair of tweezers. So if y'all, it's going to be wet and all that, and you don't know, you probably will have a hard time seeing where your solid is on the filter paper while it's still wet. So just grab a pair of tweezers, get your watch glass, and then kind of tilt your funnel to where you can just put your tweezers in the funnel, drag that filter paper out directly onto that watch glass. And do your best not to lose any of your solid. And then once you've got your filter paper on the watch glass, go put it underneath one of the heat lamps to dry. Step 13 tells you once you're solid, or you think that it's dry, right, you're going to take it out from the heat lamp and you want to let it cool down to room temperature. So if you feel like it's warm at all, then you are not ready to weigh it. If it feels room temperature, you don't feel any warmth, then you can try to weigh it. And then if your mass, it tells you if it's more than 2 grams, then either it's still wet or you didn't let it cool enough. Okay, so if it's still wet and you have a mass higher than what you should, then go put it back under the heat lamp. And then once you think it's dry, at that point, you take it back out from under the heat lamp, let it cool to room temp, and then try again. And then step 14 tells you that the filtrate you had from your second filtration can go down the sink, and then the solid that you've collected once you've gotten the mass of it, that and the filter paper can go in the trash can. So like I said, your solid is white, and I actually have some here, and so if you can tell, it's super difficult to see that solid on there. You can kind of see it caked on the filter paper, but mine is super dry, so I can actually get some off the filter paper for you. And that's my white solid. The light's reflecting, so that's not really that great. Oh, that's better. Okay, so that's my white solid. Okay. So now that we've gone through the procedure, let's talk about the data sheet and the math that you guys have to do. So For the top, you won't have the brand of fertilizer, so don't worry about filling that out. And then the rating of the fertilizer, so you'll either put whether you have 11, 15, 11. That you had. So that's super simple. Problem number 1 tells you to calculate the mass of phosphorus and the moles of phosphorus in your initial fertilizer sample. So we actually need 2 answers for this one, the grams and the moles of phosphorus. In order to do that, I've actually written it all down. We'll try to have this on the whiteboards for you guys so you don't forget, but you can also write it on your in your notes somewhere so that you have it as well. So to do this calculation, I'm up here at number 1. In your pre-lab assignment, you probably don't know it yet if you haven't done it, but you do have to calculate the percent of phosphorus in P2O5 to do, I think, your first problem. And so you'll use that percentage. And it's okay if you don't get it on your pre-lab, we'll have it in here for you, but I can't tell you now because then you'd have part of your calculation for number 1, but we'll have it for you guys so that you do your data sheet correctly, even if it's not right on your pre-lab. But regardless, so you'll need the percent of phosphorus in P2O5, and remember P2O5 is actually what's in your fertilizer, so phosphorus isn't in fertilizer by itself, it's in fertilizer as this compound, so we have to figure out phosphorus by itself. And we're going to multiply that by the percent of P2O5 in the fertilizer. We get that number from our rating. So if you remember the 3 numbers that we have in our rating, 11, 15, 11, well, in your theory, it tells you that the order of this is NPK, nitrogen, phosphorus, and potassium. So this middle number will be our percent. So since I'm using 11, 15, 11, then my percent P2O5 in fertilizer will be 0.15 for 15%. Okay, so that percentage times this percentage times the mass of my sample, which will be that number that's close to 1 gram somewhere. That will give me grams of phosphorus. So that's the first half of that question. And then the next part of that question tells you to get the moles. Well, that's super simple. You're just going to convert your grams of phosphorus to moles of phosphorus, and then that will be your answer. Okay. Number 2 tells you to calculate the mass of phosphorus in your product. So we're going to take the molar mass of phosphorus, which you would get from the periodic table, and we're going to put it over the molar mass of your precipitate. Well, the formula for that is on your data sheet. So it's ammonium magnesium phosphate hexahydrate. I think I just said that right. I hope I did. Regardless, it's the 4th thing that you weigh out. Okay, it's your white solid. So you guys need to use the masses from the periodic table, add them all up for that precipitate, and that's the number that you're going to put on the bottom. You're going to divide these 2 numbers and multiply that by the grams of precipitate, which is going to be the 4th mass that you weighed out. And that will give you grams of phosphorus. If you're not sure if you calculated the molar mass of the precipitate correctly, just ask your instructor or TA. We probably have that number. And I say that because we do have that number. So ask if you're not sure. Number 3, we are actually not going to do. That math is it has proven far too complicated, in addition to all the other calculations that we've done. So don't worry about number 3. Number 4, I'm actually going to fold this down so I can actually see. Tells you to calculate the percent of phosphorus in the fertilizer based on your product. So you're just going to take the grams of phosphorus that you calculated as your answer for number 2, and then you're going to divide by the mass of your sample, which again is the first thing you measured in the experiment. That's near 1 gram. You're going to divide those two numbers and then multiply that answer by 100, and that will give you percent phosphorus. And then for number 5, you're going to use the given formula. So it tells you, assuming the manufacturer has correctly reported the percentage of P2O5, calculate the percent error of your analysis of phosphorus. So the biggest mistake I see with this is that people either aren't sure what the number 1 and number 2 mean, or they forget the absolute value bar, and you end up with a negative number and a negative percent, which of course isn't correct. So just to clarify on that formula, it's the absolute value of your theoretical mass. That's your answer to number 1, where you got grams of phosphorus, minus the experimental mass of phosphorus. That's your answer for number 2. Okay, so you subtract those two numbers, take the absolute value, it just means to drop that negative, and then you're going to divide that number by the grams of phosphorus you calculated in number 1. So both times that it says theoretical mass of phosphorus in sample, that's the same number. Okay, and then you just multiply by 100, and that gives you a percent. So hopefully that helps a little and clarify some things. But like I said, we'll try to have these, calculation hints on the whiteboards in here for you guys in case you forget. And I believe that's it. Not too many changes to the actual experiment this time. It's pretty self-explanatory, and it usually works out all right. This one does usually take a while for some reason, and I'm gonna guess it has more to do with the math than anything else, or making sure that you have dried your sample well enough to get a good mass. But other than that, it's really not that bad of an experiment, and it's actually kind of cool if you think about it. We like the experiments where we get to see the solid products, and you guys usually are pretty fascinated with it, and we love to see you guys do all this stuff for the first time. But anyway, I hope y'all have a good week, and I will see you for the video for experiment 6.